Hello everyone, in this video I'll be explaining you the problem lasers. So it was asked in Codeforces Round 1050 for Division 4. Let's read out the problem. There is a 2D coordinate plane that ranges from 0, 0 to x, y. You are located at 0, 0 and you want to head to x, y. However, there are n horizontal lasers. So there are n horizontal lasers with the ith laser continuously spanning from x0, which is it starts from this particular line, like y is equal to x is equal to 0, and it goes till x is equal to 1. So its spanning is from 0 to x, right? And the laser will be placed at position a of I. So yeah, like from this x axis it will be position at a is equal to I, uh, and it will be spanning from 0 to x. Additionally, there are m vertical lasers from this is horizontal lasers. We have vertical lasers as well, with the ith laser continuously spanning from 0 to y. Like the lasers will be spanning from here 0 till y, and these lasers are positioned at the distance b of I. From this y axis they are positioned, sorry, from this uh, from this y axis only they are positioned till b of I. So you may move in, and don't worry, this is easy only. I'll be telling you. Just I'm reading the question. It's very easy, and I'll be at the end of the video. Will be like, okay, yeah, this was much easy. So you may move in any direction to reach x comma y. Okay, but your movement must be continuous curve that lies inside the plane. It should be continuous curve. That is very important. Okay, I'll be telling you meaning of this as well. Every time you you cross a vertical or horizontal laser, it counts as one crossing. So whenever you cross one of the horizontal or one of the vertical lasers, it will be counting as you have crossed the laser. You will be basically counting. uh, okay, so particularly if you pass through an intersection point between two lasers, it counts as two. Let's say this is the intersection point, right? We have one laser at this position, one more laser here we have, and spanning, their lights are spanning. So here is the intersection point. So whenever you move from this intersection point, since there are two lights, I mean two laser lights, so this will count it as two, that they're trying to say. Okay, for example, x is equal to y is equal to 2 and m both are 1. We have one horizontal laser, one vertical laser, and a of I, yeah, a is basically arrays. Don't worry, I'll be telling you. The movement can be as follows. What is the minimum number of crossing necessary to reach x comma y? Okay, okay, cool. So this is the example. Let's take in the input they have given test cases. So for every test case we have n m x y. Okay, and the following lines we have a1 a2 up till an, b1 b2 up till bm. So yeah, let's take this example and try to understand what they're saying. So what they're trying to say is that there are n horizontal lasers, which is given as 1, and vertical lasers, which is also given as m, and x is basically the point that they want to reach, x comma y, which is basically 2 comma 2, and your array A has 1 and array B is also having 1. Yeah, so let me try to explain what they're trying to say. So this is a 2D coordinate plane, and you are at 0 comma 0, and you want to reach to the position x comma y. Now let's try to understand if this x and y are always positive number or not. So in the question, in the test case, they have said like it is a positive integer. So x and y will always lie in the range from 2 to 10 power 9, which means your position will be in first quadrant only. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant, as you know from the math. And what they're saying is they have placed n horizontal lasers. So let's say one laser is placed here. Always the laser will be placed at this position only, because the position of the laser what they have set is okay, like you may place here also, or you may place at x also, but that is not the thing. But main thing is that it's the light will span till, let's say this is a point which is x comma y. So here the distance is x, and this distance is y. So basically this lasers span will be from at this position this to this position. So you may basically place a laser of this kind wherein laser light is here, and there are n lasers that they're saying. Let us place one more laser, and these are horizontal lasers. We have vertical lasers as well. So vertical lasers it will be spanning from as said in the question. First let me take the horizontal spanning. So what they are saying is the spanning will be from uh, a of I to a of I comma you understand the meaning of this, right? Which means this is x point and this is also x, this is y, this is y, which means the lasers placed horizontally, so it will be starting from 0, which is like this x, so whatever is there at this position x is 0, this is x is equal to 0 line, and this line whatever is saying, this line is basically uh, y is equal to x, you can think of, and this line is y is equal to 0. So it will start from this position 0 till x, 0 till x, and the y from this horizontal plane, not plane, horizontal line, how many distance it will be moving, it will be above till a of I. So in the first problem they said 1, so if you try to draw for the first case, this is 0 comma 0, and this is 1, this is 2, and this is x axis, and this is 1, this is 2, this is y axis. So they want to reach to the point x comma, which is 2 comma 2. They want to reach here, and there are n is basically horizontal lasers. So one horizontal laser we have, and its position will be always from 0 to a of I till x comma a of I. X is basically 2, so 2 is here, and it is placed at a of I. A of I means the 0th laser is placed at first position. Here the laser is placed, and its light is still here, till at this position, and we have only one, that is fine. And this is basically vertical laser, and vertical laser will be always placed at b of I comma 0 till b of I comma y, which means the y distance will be from 0 till it will be till y, so it will be till here. So laser is this way, laser light is at this position, and your x laser distance from this vertical line will be b of I. This is the b of I distance, b of I. So I think you understood, this is the position of the laser. Okay. So now what they're saying is, when you are moving from 0 basically you will have to move from 0 comma 0 to x comma y. This is x comma y. So when you are moving, so it should be continuous curve, no matter how you will take the distance, it should be continuous curve. I'm taking this as path 1, this is path 2, one more I'll be taking the straight line, this is path 3. So okay, you can't do this way, like you're moving and then raising and then you're moving, which means this is not a continuous curve, right? So it shouldn't be there, it should be continuous. So in the question that said, the path, I mean from 0 to 0 to x comma y, it should be continuous. So and what they're saying is, whenever you cross, well, let's say you're considering this path 1, so whenever you cross the laser, so it's like you'll have to count how many lasers you have crossed. So when you take this path, you have crossed one laser, and we are moving at this position, you have crossed two lasers, right? So answer is 2, but let us consider other paths as well, and I'll be telling you always your answer will be n plus m. Your answer always will be n plus 1, because what they said is you have to move in this 2D plane only. which means within this boundary you shouldn't be moving from like this position, like coming back, taking other part is not allowed. Whenever you're moving, you should be moving in this defined 2D plane, which is from 0 comma 0 to x comma y. So if you draw, so this is the area. In this area only you will be moving. You can't move from this area and move to point. So if you do that, in that case your answer is 0 because you are not crossing any laser. So I think you guys are getting right. Let me draw a bit clear image. This is the point 2 comma 2 and your laser, one laser is at this position, one laser is at this position. This is 1, this is 2, this is 1, this is 2. Okay, so laser is spanning this way. So when you try to move from here to here, so as you can see you have crossed two lasers. Okay, since there are two lasers, you will be crossing all the lasers. Now let's try to take this path. Again you are crossing one laser and two laser, and you'll have to take the minimum, right? And what they said in the question is, if you try to take this point wherein this is the intersection of the laser, so in this case since there are two lasers, so which means um, here you are crossing 2 points. In the question they've said, if you're taking this path, 1 plus 1 2 lasers you have crossed. If you are taking this path, you have crossed 1 plus 1 2 lasers. And if you're taking this path, you are crossing one laser and it has intersection of two lasers. So again here you're crossing two lasers. So that is the question, that's it. And in order to move till here, you will have to take the minimum, you'll have to cross the minimum number of lasers. You may take one more path like this. This also path you can take. If you're taking this path, see, one time you have crossed the laser, again you have crossed the laser, so it is again same laser only, so it will be counted one time only. Then this is a different laser, and since again this is same laser, so obviously like only how many number of lasers will be there, those many number of crossing you will have to do, not more than that. I mean, even if you take any path, you will be crossing n plus m lasers only. Let me try to take one more example wherein let's say you will have to move till point x comma y, and you have laser, you have let's say two lasers in this horizontal, and you have one lasers in the vertical. If you try to think of this way, so when you're moving, let's take any path you take. So in that case, see, when you're moving with this, you have crossed this laser 1, you have crossed other laser 2, you have to cross this laser 3. So all the lasers whatever you will be having, you will be basically crossing. Even if you take this path, see, one laser you have crossed, the other laser you have crossed, the other laser you have crossed, all the three lasers will be crossing. So no matter any configuration they give, so basically your answer will be n plus m, the number of lasers in the specified boundary. So I've actually coded it up here, but let me code in front of you. We have test cases, so test cases I have taken care of this position. For every test case we have nmxy, nmx and y, right? Let's take their values, and in the next line we have n integers. Okay, let's take vector of type int, let me call as a, it is having size a, and vector b of size m. Like two vectors there, this is basically not necessary. So even if they have given you, just take it, but your answer will be always n plus n. So yeah, we'll have to take these values also because they are giving. So let's take values a and b. These are basically the positions of the horizontal laser, and these are positions of the vertical laser, right? Once you've taken those values, you will have to just display n plus m. because the number of lasers in vertical and number of lasers in horizontal, all the lasers will have to cross. So yeah, let's try to submit. Yeah, we have lasers here. Yeah, it got accepted. I think you guys are clear, right? Basically, no matter how many lasers they place in horizontal or vertical, when you are moving continuously, so in that case, you will have to cross all the lasers. So in this case, your answer is basically n plus 1. Yeah, so thank you guys for watching the video.